Okay, so here's how you do problem number 44, which asks us two things: how many electrons can be in the n equals 4 shell, and what are its subshells and how many electrons can be in each. So the first thing we need to do is figure out how many electrons we can have. From the lecture video, tells us that at about 19 minutes and 40 seconds in, it tells us the total number of electrons inside of an atom of an orbital of quantum number n is 2n squared. So for part A, the number of electrons is going to have to be equal to 2 times n squared, which gives us 2 times 4 quantity squared. That's 2 times 16. So that's a total of 32 different electrons that we can have. Then part B asks us what are the subshells and how many electrons can be in each. So subshells are the L's that I can have. And I can have L's anywhere from 0 all the way up to n minus 1. So if n is equal to 4, I can have 0, I can have 1, I can have 2, I can have 3. If I write down 4, I can't have that because I can only go up to n minus 1. So get rid of that 4, and these are my subshells. L equals 0, 1, 2, and 3. Now how many electrons can be in each of these? So the L equals 0 state, which sometimes we denote with the letter S, can have 2L plus 1 states. That's 2L plus 1 different ways the electrons can be arranged. That is in the lecture video at about 2021. 2 times 2L plus 1 is the number of different ways you can organize your electrons in this state. So I can have in the L equals 0, 2 times 2, plug in your 0 for L, plus 1. So that's going to be equal to 2 states. L equals 1. That's going to be the P state. For the P state, I can have 2 times 1, where I'm plugging in 1 for L, and I plug in these numbers. I get 2 times 2 plus 1 is 3. That should be equal to 6. For L equals 2, that's going to be the letter D, denoted with the letter D. That's going to be 2 times 2 times 2 plus quantity 1. So I have my 2. I multiply those two numbers together, the 2 times 2 to get 4. So 2 times 2 is 4, plus this 1. So this is going to be 2 times 4 and 1 is 5. 5 times 2 is 10. And then I've got the final state. L is equal to 3. That has the letter F that goes along with it. That's going to be 2 times 2 times 3 plus 1. So that's 2 multiplied by 3 times 2 is 6 plus 1. 6 and 1 is 7, so that's 2 times 7. 7 times 2 is 14. So that's all the electrons that I can have in each of these subshells. Subshell 0 can have 2, subshell 1 can have 6, subshell 2 can have 10, subshell 3 can have 14. And if I add all these numbers together, 10 plus 14 plus 6 plus 2, that gives me 32, which is the total number of electrons I can have in my atom from in that n equals 4 state from the very first part of the problem. So that is how you do problem number 40.